I'd like to welcome everyone. I'm Dylan Switzer with CAD Dimensions. I'm an application engineer here. I'll be speaking today about Polyjet and some of the basics behind it. To get started, we start out with the agenda for today's presentation. Give everyone a minute to read through this. I'm going to start this presentation out with the basics of what exactly is Polyjet. So this is a screenshot taken right off of Stratasys' website, where they describe Polyjet as one of the most powerful 3D printing technologies available today that does a great job at smooth, accurate parts with microscopic layer resolutions down to 14,000ths of a millimeter. Excels at thin walls and complex geometries with the widest range of materials available. So, in other words, Polyjet is the only platform that allows you to print multiple materials parts with unrivaled realism, all on the same build tray. It has like I mentioned earlier, the widest range of materials available, ranging from full color rigid materials to flexible and transparent materials. Kind of opens up the possibility of what you can do with Polyjet. Not only is those materials, but also special materials available for dental and medical applications as well. So how does Polyjet work? Effectively, photopolymer resins are jetted through a microscopic nozzle that lay down material one layer at a time. So each layer is laid down. A UV light passes over afterwards to cure it to solid. The resin uses are cured by this UV light, leave them solid, and after that layer is down and cured, the build tray drops to allow you to start the next layer. You can kind of think of it as an inkjet printer, but instead of just printing in 2 dimensionals, we're able to print on top of it and drop down to add a 3rd dimension. So why choose Polyjet? If you need high detail and complex geometry like this architectural model, the thin bars in the windows here would be very difficult in a lot of other technologies, but Polyjet does a great job at getting these done well. If you need to accurately communicate color, Stratasys Polyjet technology had the only Pantone certified printers available in the market today. If you need to print multiple materials in the same build tray for hyper-realistic parts, for example, the shifter in the upper right corner, we're able to print real feel simulated leather along with hard plastic with a texture mapping on it to give you great looking parts right off the build tray. Or like the headphone case down below, where you've got simulated polypropylene along with soft touch rubbers, all printed on the same build chart at the same time. Or if you need parts that convey your final product's aesthetic, the use of 3MF files and other similar manufacturing files allow you to print textures that are generated right from your rendering programming, like Keyshot. So what materials are available? We've got 3 families, starting with the Vero family, our functional family, and the medical family. Getting into the Vero family, this is kind of the bread and butter for a lot of Polyjet parts. So it's our rigid full color option. And it can all of these colors can be combined together to create a full color spectrum. These are great for prototypes, design verification, some light fixturing. Like I said, it's kind of the bread and butter material of Polyjet technology. So it's almost every Polyjet part is going to have at least a little bit of Vero in it. Also available is our Vero Clear option. This is our simulated acrylic. It's obviously our transparent material, hard rigid. Also available, there's 2 formulations available, the standard Vero Clear along with the Vero Ultra Clear, which is a digital material, meaning that it combines with the standard Vero Clear to give you increased light transmission for parts thicker than 3 millimeters. The reason it has to be thicker than 3 millimeters is because we use that Ultra Clear material to coat standard clear, and you need a 1.5 millimeter clearance on either side in order to get the advantages of the Vero Clear. These are great for concept modeling, design verifications, clear parts, eyewear, light cover, medical devices, anything you need a clear material, Polyjet Vero Clear is the answer. Next would be our draft gray material. This is another rigid material. What really makes this shine is it's the cheapest and fastest material to print if you've got your printer set up in your super high speed mode. It's great for projects that require lots of iterations or that you're going to send off to the paint booth anyway. You'd be able to get a bunch of different iterations off on the same build tray, cheap and fast. Next, we'll get into the functional family of materials that are available, starting with Agilus 30. This is a flexible Shore 30 simulated rubber material available in 3 color options: a transparent, white, and a black. And this again can be combined with other digital or Vero materials to create a full color spectrum or variable Shore values. The trade-off being, if you need a more rigid part, you'll have more Vero in there, so you'll get more brighter colors. If you need a more flexible part, you'll have more Agilus in there, giving kind of muting some of the colors because you only have the transparent white and black available to mix in with that. This is great for prototypes, for overmold, soft touch parts, gaskets, hoses, anything that needs a soft touch rubber feel to. Next, we'll get into the digital ABS material. So this is another 2-part material, so it requires 2 material bays to use this material, available in both a white option and a green option. And this is a simulated ABS. It allows you to get the same material properties as some of the FDM ABS, but with the great surface finish and complex detail available on Polyjet. This is great for functional prototypes, some injection molders, more complex fixtures that need a little more hardier material. Next would be the rigger material. This is our simulated polypropylene. It's available in a bright white. This is great for form fit function tests where you can really do some real feel testing. In this part, even they've included a little bit of Agilus around the outside to give a nice sealing gasket. You can really test and get a good idea of how exactly your part's going to work at the end before investing in expensive tooling to figure out your design needs a little work. Let's get into our medical family. We got our digital anatomy material, excuse me. First one would be the bone matrix. And what makes this material special is it's not designed to look like bone, but more to feel like bone when you're really cutting into it and using tools. And combined with GrabCAD print settings, we can use that to get the real textures of actual bone on the inside, so you can get realistic feels when you're cutting into drilling it. This is great for protecting medical parts that we don't have to invest in getting a cadaver or anything like that. You don't always just need bones. There's also a tissue matrix available that allows you to print realistic organs that feel just like as if you're cutting into actual flesh. It's really nice for that we're not having to invest in cadavers, like I said. And the third material available would be our gel matrix. This is really specialized for capillaries and vascular type structures. It also is a gel support material, which helps us clear out and print these and clear it out, so we get flow simulations and whatnot in actual vascular like structures. Also available is a variety of dental materials. Stratasys offers an entire line of printers and materials specifically for the dental industry. They have materials that are biocompatible, so they're certified for temporary in-mouth placement. So the dental applications are huge, ranging from just cast realistic, the one on your screen, or surgical guides, clear aligners. The possibilities are really endless. So how do you know what material to choose? You've got to kind of prioritize a little bit which you prefer. If you need high detail, close visual representation of your final product's aesthetics, the Vero family is going to be great. So for example, the hard casing on the outside of this drill, this is all done with the Vero material to give it the real look of the part, of a production part. If you need realistic functional parts to run realistic tests on, then you're going to use more of the functional family. So for example, this drill part has some soft tough rubber on these overmolded parts, so you can get the real feel of what the rubber grip is going to feel like in your hand before going to make a final production part. Or if you need medical models that react exactly like true human flesh or materials like that, our digital anatomy materials on our DAP printers is the option for you. And again, the best part about Polyjet materials or Polyjet technology is that you don't need just one of these. You can have all 3 of these available in the same build tray if you've got your machine set up properly. For example, the drill part, like I said, it has both soft touch Agilis material and the hard rigid to give a nice looking part while it's functional at the same time. Next, we'll get into the workflow. So on your screen now, you'll see a screenshot from GrabCAD Print. This is the software where you do all of your processing for Polyjet, and actually all of Stratasys printers. So you're going to start with your model. GrabCAD can take pretty much any 3D file, STEP, STL, 3MS, and even CAD native files, which is really nice. The parts on your screen right now were loaded with a 3MS type file, so all of the colors and textures that we wanted in this part were already included in this file type. But if you're working with simpler models like STL or steps, we'll talk through the process of how you can assign those colors and whatnot in your workflow. So first, you want to do is import your model into GrabCAD. There's a couple ways to do that. You can either click the Add Models button, or you can just simply drag and drop your models right into GrabCAD. So after you've got your models into GrabCAD, you want to make sure you've got your correct printer selected. So in the bottom right is where you'll select here, and when you click that, you'll get this pop-up. And from here, if your printer is networked in, you'll just simply select your printer. We've got a template printer just because it's a practice run. But when we're actually printing, we'll select one of our printers listed out. After you've got your printer set up, you want to make sure GrabCAD knows what materials are configured. So you're going to want to make sure you've got your loaded materials set up properly. So if you go to your tray settings here, you'll get this pop out. And notice this has an orange message saying that the tray isn't set up properly. So in order to do that correctly, we have to click this change button, and that'll open up this pop-up where if you have certain materials you're planning on loading into material, you can select them, or you want to just use the ones that are loaded in material currently, just click this Get Printer Loaded Material button, and it will automatically populate the materials that are loaded in your printer currently. And by clicking Save, your printer is all set up in GrabCAD. Next thing you want to do is orient and arrange your parts on the build tray. So on that right side of GrabCAD, you'll use this icon here to orient your parts. You can either change them via a rotational, or if you want to use the orient face to plane, that's kind of the feature I use the most, especially for Polyjet when I've got to print like a glossy part. There's a glossy setting available on Polyjet, but you can only have the glossy surface finish on upward facing parts. So if I know I've got a part I want to hit that glossy setting on, I use the face to plane to select that face that I want glossy and select it upwards, so that way it can print glossy for me. After it's oriented properly, you want to arrange it on the tray. And what's really nice is you can just click the Arrange this tray button, and GrabCAD will automatically place it in the optimal position on the tray for you. After you've got your parts set up in the proper orientation and location on your build tray, this is where we'll go through and we'll assign our different colors and shore values if it isn't already set up in your part file. As you can see, there's a few different ways we can do this. There's the color picker option. You can use just the tray materials or what's loaded in your printer. Your digital materials, where you combine your loaded materials and you create that's where we would do our variable shore value, or if you know your CMYK input, or if you have a Pantone color you want to select. So that's what some of these look like. Over here on the left is the color picker option. So as you can see, you've got a few sliders for the colors you'd like, and you can kind of really fine tune the full spectrum that the colors you'd like to pick. As a note, we've got Agilis clear loaded in this machine, so we also have an option to change the shore value. But when we're using digital materials, again, some of the color accuracies might not be there because we have to trade off the full color option to get your more flexible material. So they give you a preview of your selected material and then what the printer actually is going to print out. So you can use that as a tool to make sure you get the correct color you want. However, when you're using the Pantone colors, you can go through and just select the Pantone callout color you're looking for. And then over here on the right is the digital materials. So for this example, we were trying to do a variable shore gray color. So we picked our Vero black and combined it with our Agilus clear. So on the right here is a fully rigid black, and on the left would be a shore 30 gray that has just a little bit of Vero in there to get it just a little bit of color. But as you get a darker or a more rigid part, you'll get a darker color because it has more Vero, and a more flexible part will have less color and more grayed out and muted colors. After you've got your part set up properly, you can click the estimate print button, and this will give you your listed out material, your print time, and your material usage. It looks just like this. This is the print estimate from that tray we installed earlier with the headphone model. Once you're happy with that, you can go ahead and hit print, walk over your printer, and hit start on your printer. This is a video of our J55 printing. I want to point out the one thing that's a little different than most Polyjet printers. J55 is our newest one, and they've changed around some of the movements. Previously, the head would move in an X and Y motion. They wanted to cut down on the accelerations of the head block moving. So instead, they have a rotating build tray to cut down on the movements of head, and this leads to faster print times and more accurate parts, along with less needed for maintenance. As you can see, the purple light on the right is that UV light that's curing each layer as the tray rotates. The J55 does 4 revolutions per layer to, yeah. So once your part is finished printing, you can go through and open the part up and remove it. On the J55, like I said, it's a rotating tray, so you want to make sure you lock it into place so your tray doesn't move on you. You do that by just pushing that button right there in the front. And we use a large putty scraper to get underneath the parts and pull them off the build tray. And you'll notice the white material around all of the parts. A lot of these were printed in the matte setting, and that's because we wanted a uniform surface finish on the entire thing. In order to do that, they coat the entire part in the support material to get that same surface finish on the entire part. Once your part is off the printer, the next step I like to remove as much support by hand as possible. This step is optional. It's not entirely necessary, but I think it speeds up the support removal process, in my opinion. So I like to try and break off all the support material as possible. We use some just simple clay forming tools to just scrape the big chunks of the material off. Notice I don't get this whole top surface, but that's all right, because in the next step, we go over into the water jet, where we'll finish cleaning off the support material with effectively a small pressure washer, enclosed pressure washer. We go through and we spray off the remaining support material. Like I said, you could just skip right to this step and spray off the big chunks as well, but it goes a lot faster and a lot easier if you get those big chunks off first by hand. Once you're confident you've gotten all the support material off, simply just let the part dry and it's all done. So this is that part that I was just showing you cleaning off. It's a great part. It's got the matte surface finish on the top, and the little headphone parts actually had the glossy surface finish. You can see a little bit of shine. And that's my overview of the Polyjet technology. If you guys have any questions, you can go ahead and unmute yourselves and ask away. So looking at the question about maintenance. Yeah, so the Polyjet material or Polyjet printers do require a bit of maintenance, but it's a relatively simple process. So I would recommend cleaning the print heads after each print you do, and at least on a weekly basis. What that process involves is simply taking a isopropyl soaked rag and just doing a couple passovers over the print head and the wiper just to make sure that the photopolymer resin doesn't get stuck on them and hardens up where we don't want them to. And there's specifically the J55, there's some really easy user-friendly wizards that are involved. So you simply go through the settings and just start the wizard, and the screen will walk you through every step you need to do. So specifically on the J55, there is 7 material channels, I believe. Could be wrong on that. I'd be confusing with the bigger machines. But there's typically a channel for each material, and there's 2 bays for each channel. So for example, there's a top and a bottom bay for your yellow, top and bottom bay for your cyan, a top and bottom for your clear, top and bottom for your magenta, and a top and bottom for your support. And those are hot swappable as well. I believe the J55, as soon as there's a question about cost of the J55, I believe it's a $100,000 machine, but you can get with a sales rep and they'll get you a tighter quote on that. So there's a question about the water jet. So it is there is a pressure washer that's built into the water jet. It's an enclosed chamber, and you run a hose to an actual electric pressure washer, and it hooks up to a foot pedal that you use to pressure off to blow off the support material. Yes, that is a secondary piece of equipment. So there's a question about what water jet. If you guys want to send me an email offline, my email is dswitzer@caddimensions.com, and I can get recommendations out to you for you. So the support, there's a question about the support being water soluble. It's partially water soluble. So if you let it sit in a tank, it'll start to fall away slowly. But you really need that pressure and a little bit of agitation to actually get it fully off. But it's very easy. If we've got some parts that we want to be very careful with and we're worried about them breaking, we'll let the part soak overnight to let that support material soften up a little bit, and then brush it with a toothbrush to be very careful and make sure we're not breaking the parts. On the big box machines, the J850 and etc., there is a soluble support material option, and in which case you can put it into basically a detergent bath, and it agitates the solution and will slowly dissolve away the support material. However, on the J55, it's a water-based material, so you don't need that particular detergent to wash away the support. Nope, the water jet system can be purchased directly through your Stratasys reseller. So there's an question about the max angle for support. Because we're working with a liquid resin material, there are no self-supporting angles. So as a note, we can't make hollow parts in Polyjet technology. The inside would have to fill with support. That's one thing also to note. Anywhere with support with touches, you won't be able to get that glossy surface finish. That's another design note. Yep, exactly. So if you've got a hollow part and you leave a hole in there, that's the best way for you to dissolve out that support. It's going to take a little longer because you've got to make sure you can get liquid in there and circulate it around to actually dissolve out the support and get it out. But that's the process people use if they want to print a hollow part. So for support 710 on the J55, it's just plain tap water. However, on the big box Polyjet machines that use the soluble support, I believe it's a 706, that's a sodium-based detergent. I can't remember exactly what the material is. I believe it's a sodium bicarbonate, actually, the more I think about it. All right, so it looks like questions have flowed in, so I'm going to wrap this up. If anyone has any questions that aren't answered or want to talk to me offline, again, feel free to reach out anytime. My email is dswitzer@caddimensions.com. Thanks again for joining us today. Have a good day, everybody.